Hi, in this class I'm going to talk about sampling distribution of the proportion, and what we are doing is we are trying to determine the proportion and the standard deviation of proportion using a sample, an estimate to a population like we did for the mean. Now we're doing for the proportion, and the idea is the same. We want to know what the proportion of certain characteristic in the population when we don't know, and then we use a sample to get data and compute the sample proportion and try to estimate that value for the population. So the expected proportion for the sample, again, we are talking about the sampling distribution of the sample proportion. P-bar is sample proportion. And the sampling distribution is composed of the expected value and the standard deviation. So this is always these two pieces of information that you need when we're talking about the sampling distribution of sample proportion or sample mean, is the expected value and the standard deviation. So the expected value of the sample proportion is equal to the proportion in the population, always. There's nothing here to compute. You simply assume that the sample proportion is equal to the population proportion. But for the standard deviation of the sample proportion, you have two formulas, like very similar to the process we have for the sample mean. We have the finite and we have the infinite population, and the both standard deviations are using this formula, which is square root of proportion 1 minus proportion divided by the sample size. And in the case of finite population, we have to include this correction factor. Okay, and the sampling distribution of the sample proportion can be approximated by a normal distribution always when the sample size is large enough to satisfy these two conditions. So this is an additional step we have to compute in order to understand or estimate the sample proportion. Okay, we have to compute the sample size multiplied by the proportion, and the resulting number has to be higher than 5. And we have to compute the sample size multiplied by 1 minus the proportion, and also has to be higher than 5. Okay, if these two conditions are satisfied, we can move ahead and keep working on the problem. That's basically what we're doing here. So let's see one application. Again, we have the EAI employee data, and we have a proportion of employees participating in a management training program. The proportion is 0.6 in the population. So we want to know what's the probability that a sample of 30 employees will provide an estimate of the population proportion of employees within plus or minus 0.05 of the population proportion. So I'm going to add and subtract 0.05 to this proportion, and I'm going to compute the probability of having population mean within those numbers. So let me show you this. This is what we're doing. So we get the population proportion, and we add 0.05, which gives us 0.65, and we subtract 0.5, which gives us 0.55. So this is the area that we're interested. What's the probability that a sample of 30 employees will be around this population mean? Okay, so this is what the problem is talking about. So let's take a look at the steps. First step, check to see if these two conditions are satisfied. So the sample is 30, proportion is 0.6, resulting number is 18, is higher than 5, is good. The other one is 30 multiplied by 0.4, 1 minus 0.6 is 0.4. If I multiply those two numbers, I have 12, which is higher than 5. So the conditions match. Perfect. We can move ahead to step 2. Step 2 is calculate the ratio sample size over population size. Is the same as we computed for the sample mean, because it's the same like problem. So the proportion is, the ratio is, resulting number is 0.01, which is smaller than 0.05. So because of that, we don't need the correction factor. We can ignore and use the simpler formula. Which formula? This one. Okay, we can, because the resulting ratio is smaller than 0.05, we can use this formula here. If the ratio is higher than 0.05, then we have to use this formula. Okay, so step 1, step 2, we know which formula to use to get the standard error of proportion. So this is the application of the formula. Square root of 0.06 multiplied by 1 minus 0.06 divided by 30. That's the resulting number. And then we compute the upper end point and the lower end point of the interval, like we did for the case of the previous problem. Remember this problem? And then that's like lower and upper end points. Now what we have, as I showed you in the other problem, what we have is 0.6, I add 0.65, I add 0.05, and I subtract 0.05, so it's 0.55. So this is the area we're looking for. This is the upper and lower endpoints that I'm talking about here. Okay, so this is what we did, and then we use the Excel function, that the same one we used before, you learned in the previous chapter, and then you get the area, the areas here, and then we compute the probability. Let's take a look how to do that in Excel. So this is the same Excel file we have for the sampling distribution of the mean. I included a worksheet here. So step 1, I populated all the cells because it's the same thing. I don't want to spend time populating the cells again. So the only additional, there's maybe 2 or 3 things that's different that I'm going to highlight. First one is to compute the n multiplied NP, which has to be higher or equal to 5. So how I compute that? N is 30 multiplied by 0.6, that's 18. The second condition is N1 minus P has to be higher or equal to 5. So this is equal to 30 multiplied by, open parentheses, you have to open parentheses, and you can do 0.4 directly because 1 minus 0.6 is 0.4, or you can do 1 minus 0.6, which is 0.4. The resulting number is 12, so both requirements are met. Step 2 is compute the need for the correction factor, if it is infinite or finite population. And then we can move to step 3. Step 3 is to determine the standard error of proportion, standard deviation of proportion, and this is the formula, square root of P1 minus P divided by N. So the formula we can implement is like this, equal SKRT. SKRT is a function for the square root, open parentheses, and then I open parentheses again because what I want to do is I want to do P minus P1 minus P. Let's take a look at the formula again to not. So the formula is P multiplied by 1 minus P. So it's P is 0.6, the proportion, minus 0.4, because 1 minus 0.6 is 0.4, divided by 30, which is the sample size, okay? And that's the answer. Like if we 0.894, ours is computed using Excel. This one comes from the book, is a little bit different, but very close. Then step 4 and 5 is compute the upper and lower ends of the interval. We did that, 0.65, 0.55. And now we use let's use the Excel function norm.dist. So what is the x value for the upper? Is the 0.65. Type, what's the mean? The mean is 0.6 given in the problem. The mean, in fact, is the proportion. And the standard deviation here is this standard deviation of the sample proportion. You compute it and you type 1, and then you get 0.7298 or 999. So I put 0.7299, rounding up the number. Okay, the second one is equal norm.dist, the lower endpoint. The mean, which is the proportion, is 0.6. Standard deviation is given for this computation. Type 1, 0.2701, 0.2701. And then after computing the areas, what you have to do is subtract one from another. 79. So when we compute, the final answer is 0.4597. So this is the probability, okay? This is the probability we think. This comes from the book. Here the final number is a little bit different because we're using Excel and the book's probably not using Excel. So, okay, so this is how you compute the sample, the probability, answer the problem of the probability that a sample of 30 employees will provide a population proportion, an estimate of the population proportion within plus or minus 0.05 of the actual population proportion, okay?